Okay, good morning, everyone. Okay. I guess I don't have to start as every day. You guys know the drill. Number 40. Okay. So the main idea is a geometric series. That's what this whole section is about. Is a specific type of series, specific type of sum. I mean, series, or actually it's nothing more than sum. Means we are adding terms that have the following form. That's what geometric, very specific kind of sum. So we keep adding, and the general term is A R to the k. So that's the general term of the sum. That's the general term. And this is in sigma notation is A R to the k, k starting from 0 to infinity. And the main idea is that if R is this constant multiplier, so that's the constant multiplier. If this R is less than 1 in absolute value, then the series converges. It means as we keep adding more and more terms, we approach a finite number, and the sum is the first term times 1 over 1 minus the ratio, which is R. And if R is bigger or equal to 1, then the sum doesn't go anywhere. Either go to infinity or it doesn't approach any fixed number. Okay, so everything is based on those criteria today. So I'll look at your problem. So I will look at number 40. And number 40. All right, so we have the following sum. K equal 1 to infinity of 3 times minus 1 to the power 8, the whole thing to the 3k. Okay, so first, a geometric series has the form R to the k. So we don't quite have the exact format. So one of my advice to you is write usually the first few terms of the sum, of the infinite sum, because it helps us a little bit interact with it. So the first few terms are 3 minus 1 to the power 3. Plus, I'm going to write it in two ways. First, verbatim, what I see. 3 times 2, which is a 6, plus 3, k equal to 3, which is a 9, plus etc. Okay? So that's by writing the first few terms, which is basically equal to minus to a power 3, that's a minus sign, 3 times 1 over 8 to the power 3, plus 3, 1 over 8 to the power 6, minus, so it's nice to see this where the sign are alternating back and forth, plus so on and so forth. Okay, so now the question is the following. Question number 1, is it geometric? It means, do we go from one term to another by multiplying by the same ratio? And if it is, what's the ratio? Okay, so what do we multiply by, going from one term to another? Now it's up to you.
Negative 1/8 cubed.
Right, we multiply by negative 1 over 8 to the power 3. From here to here, we multiplied by negative, of course. From 1 over 8 to the power 3 to 1 over 8 to the power 6. To get from here to here, we have to multiply by 1 over 8 to the power 3. The same goes here. From here to here, we multiply by minus. To go from 1/8 to the 6 to 1/8 to the power 9, we're multiplying by to the power 3, and so on and so forth. So that's my constant multiplier. So this is geometric series where the ratio is minus 1 over 8 to the power 3. That's my ratio. It's minus 1 over to the power 3. Now the ratio is absolutely less than 1. It means that the sum or the series converges. Means if I keep adding and adding, I'm really gonna get somewhere. So what's the sum? So now we apply the formula. So the sum, it means if I add those terms, equal to the first term. So what's the first term? I will write, so I know what the ratio is, I need the first term. The first term is exactly the first term. That's what it is. So it's minus 3 times that. That's really what we mean by the first term. So it's going to be equal minus 3 times 1 over 8 to the power 3 times 1 over 1 minus the ratio, which is minus 1 over 8 to the power 3. And now the rest is algebra. There is really nothing left into this problem. So my sum is...
I have a question.
Yes.
I know this is a weird question, but it can be negative, right? Like the answer?
Of course.
Okay, no, it was just weird seeing a negative answer yesterday.
Yeah, I know. A lot of things are going to be a little bit weird for you in this section, but you will get used to it because it's a very new idea. Yeah, I'm aware of that. Because you're adding, when think about adding numbers. Can you have a negative number?
Yes.
Yeah, it's 2 minus 5, you get a negative number, minus 3, right? As simple as that. What we're doing here, we're actually adding, and we're adding positive and negative number to each other. So we're not only adding positive numbers. That's negative, that's positive, that's negative. And what we are doing, we're adding infinitely many terms. That's what we're doing. We keep adding, we keep adding, we keep adding. Those are my partial sums. And I ask myself, are those partial sums, are they blowing up or they are getting close to a finite number? Okay, but physically what we are doing is really, we are actually physically adding. So the finance is equal to minus 3 times 1 over 8 to the power 3 times 1 over 1 minus is a plus 1 over 8 to the power 3. So a little bit of math will get me to minus 3 times 1 over 8 to the power 3. Now, if I find a common denominator here, 8 over 3 will be a common denominator. So I will have 8 over 3 plus 1 divided by 8 over 3. It's just multiplying the numerator by 8 over 3. So finally, I will end up with minus 3 over 8 to the 3 plus 1, which is, I have no idea what it is, but you guys can figure this out.
Wait, so why are you, I don't understand why you're multiplying by what was it, the 1 over 8?
Repeat your question, please.
What was that?
Repeat your question.
Oh, so I don't understand why you're multiplying in particular.
Where? I don't where. Which stage? Here?
Yeah, because on the homework, what I did is I just did like the normal series as if it were starting at 0 and going to infinity, but then I just if it had like, let's say it was starting at 1, I just like removed that from the series as opposed to multiplying. So I was confused why you were multiplying by the 1 over 8
You
cubed
can
in
do
particular.
it by this term.
Yeah, well, I understand the 3 because you always have to obviously multiply by A.
Yeah, the formula tells you it's usually that's what really the formula is, the first term. So because I'm starting at 1, I'm not starting at 0. So my first term is going to be actually that one.
Okay.
So I don't have, in your case, the way you're doing it is correct, but it's actually more complicated. because
Okay.
you're doing it from 0 to infinity, right? And then you're gonna subtract something from it.
Okay.
So the formula goes, that's why I wrote the formula yesterday in class in this way. I wrote it as the first term times 1/1 minus the ratio. That's the easiest way to memorize the form. It means regardless what the first term is, whatever it is, it's the first term times 1/1 minus the ratio. So in my case, that's the first term.
So then what happens if k starts at like 3, for example?
The first term will become, so if you start at 3, the first term will become minus 1/8 to the power 3 times 3, 9. That will become your first term.
Okay.
What I
That
mean?
Yeah, I think that makes sense.
Yeah, the first term, whatever you are, whatever the first term, when the geometric series, but that's where the geometric series should start. Wherever it starts, that's your first term. That's why I'm advising you to write the first few terms so you can use it correctly. That's your first term here. Okay, because I'm not starting at 0. Please
if you go back to that equation.
Yeah.
Okay.
Okay, that's the first term, whatever it is.
Thank you.
But they cannot, when they give you the formula, what's going to happen, they cannot tell you they have to start somewhere to give you the formula. They cannot tell you what to do for, if you start at 1, what to do for k equal to 2. So the formula, they have to give you some kind of, a rule, one rule. But the way you read it is always where you start the first term times 1/1 minus the ratio. Okay. So starting from 0 is more difficult. No, it's not. It doesn't matter. The formula, the same thing apply. So if you are doing it, you start from 0, then you have to take away something. You have to take away the first term. You cannot apply it from 0, and it is from 1 here. So this is going to be equal to minus 3 over whatever this is, and you're done.
I have a question.
Yes.
I used a different ratio for my homework for this problem.
Oh, okay.
And I gave me the right answer, so I don't know if maybe it was just by chance, but I used -3/24 for my ratio.
What? How?
Like I multiplied out the 3.
It doesn't work.
No? Okay.
No. It doesn't work because let's see why. I don't know how it gave you the right answer. I have no idea. But let's see why it doesn't work. Okay, I know what you did, but let us really discuss it. I know what you did. So you did the following. You did that. You multiplied 3 by 1/8 to the power 3, correct? And this gave you it doesn't, I mean, there is no way it's going to work. So you use for ratio 3 times 1/24. Was this your ratio?
-3/24 cubed.
Where is the cube?
I'm sorry? Oh, for the I used 1 minus
What is
-3.
the ratio? What is the use for ratio? That's what I want.
The ratio I used?
Yeah.
-3/24 cubed.
The 24 is cubed.
No, the whole fraction.
The whole fraction is cubed.
Yeah.
Yeah, but this is the same thing as 1/8.
Right. Yeah, someone in the chat said that.
Ah, okay,
Yeah.
okay.
That's
okay.
why I didn't think that out. That's my bad.
Okay. Yeah. I mean, yeah. All right. I said impossible to give you the same answer. Okay, now I see what happened. Okay, before I move on to the second question, I want to ask you just to practice our sums. Practice writing the sum correctly. This expression, -1/8 to the 3k, 1 to infinity. If we want to write it into this format, that's the 3 r to the k, something like that. What will be, how can you rewrite it so it will have the format, exactly the format of a geometric series?
You can bring the cube in,
Cube what?
the -1/8.
Right. So you can write it as -1/8, the whole thing to the power k. And now this shows that that is exactly the same thing as, that show me the ratio here. So it's nice sometimes to see how to rewrite a sum so things will work. All right. Now we move on to your other questions, number 40, 29, and 77. Right. 29 is about what? So it's the sum of e to the -2k, k equal 1 to infinity. Okay, all right, so again, we will write it. We will write the first few terms just to make sure that it is a geometric series, because writing out it will be easy. So for k equal to 1, I have e to the -2 plus e to the -4, e to the -6, etc., etc. So my general term is e to the -2k, and so on. So now the question is geometric. What's the common ratio? Means every term is the term before it multiplied by what? Very quickly, this is not hard. Exactly, so it's 1 over e squared or e to the -2, whichever you prefer. So every time I'm multiplying by e to the -2. So my ratio here is e to the -2. It's less than 1. It means the series does converge. Means if we add, we get somewhere. We don't go to infinity if we start adding them. So the series converge. And the first term here, so I'm going to use the idea of the first term because that's the one I want you to use because it's easier. It's 1 over e squared. And now my sum would be equal to. It means adding those terms, I'm going to rewrite them as 1 over e squared because I think it's actually better this way. So if I add those terms, keep adding them, I will get the following. The first term, then 1 over 1 minus the ratio. And now the rest is simple math here. Common denominator is e squared. E squared minus 1 divided by e squared, it's like multiplying by e squared. So this would give me 1 over e squared minus 1.
I have a question.
Yes.
If it starts out with just like a bunch of numbers, like I don't know, like 1 plus 1 over 1/2 and all that, like you know how it's not like sigma notation form, but it's just like a row of numbers, maybe like 4 of them. Do we have to make it into sigma notation, or do we just go from there?
It depends on the question.
Oh, okay.
Yeah. If I ask you to write in the sigma notation, then you should. If I don't, you don't. Right?
Okay.
Now, how can we're gonna rewrite this again? We can rewrite this so we can, as I said, we practice again to see it as geometric. It means I want to rewrite it so it shows like r to the k. So the best way we can rewrite it is e to the -2 to the k. So my r now is e to the -2. Okay. All right, very good. So we're going to finalize the geometric series. And let me see what you guys ask. We have to look at number 77. And then we proceed. So what is 77 about? Okay, they are all basically the same type problem. And here they are starting again from 1. They don't have to. Minus 2 to the k over 3 to the k plus 1. Okay. Equal. Equal. Before I write the first few terms, which is the way I will always do it, who can rewrite this just to practice our sum? Who can rewrite it as something like that? Who can rewrite it a times r to the k?
Be 1/8 multiplied by negative 2/3 to the k.
Repeat so I can write verbatim what you said.
1/8.
8.
Yeah. Oh, I'm sorry. It'd be 3. 1/3.
Okay, that's what I was wondering.
Yes.
Where's the 8 coming from? 1 over 3.
Multiplied by negative 2/3 to the k.
Absolutely correct. And my r is going to be minus 2/3 immediately in this particular scenario.
How did you get there?
Very good. How did he get there? How did he get there? So I'm not solving the problem. I'm just playing with notation because we have to. How did he get there? Can anybody kind of figure it out? So forget about this. I'm going to spell out this clearly. 3 to the k plus 1. Okay, so his idea is he want to write sum to the power k. So what he did was the following. Minus 2 to the k over 3 to the k plus 1. How did he split it? 3 times 3 to the k. Because 3 to the k plus 1 is 3 times 3 to the k. You add the power. Once it's have exact this format, and then he's put it everything to the k together. I stop. Is it making any sense?
Yep.
Yeah, that's exactly how he fixed it, how he rewrote it. Okay, so it's just managing notation, understanding notation, and how we might manipulate them. All right, now I go back to the problem. Now, of course, once you write it this way, this is going to be my R, it's going to become clear. But still, as I said, I advise you to write the first few terms to interact more and more with those problems. And actually, it's right there now. We see what's going to happen. All right, for the first term, k equal 1 minus 2 over 3 squared. For k equal to 2, I know that the signs are alternating. So I know that k equal to 2, this minus 2 to the power 2 will become positive, and I'm going to have 2 squared over 3 to the power 3 minus 2 to the power 3 over 3 to the power 4, and so on and so forth, etc. So that's really, so again, what's the constant multiplier? Every term is obtained from the one before it, multiplying by minus 2/3, multiplying by minus 2/3, and so on and so forth. So now the ratio is minus 2/3. In absolute value, it's less than 1. It means adding those terms, it will converge. And it converges to what? What does it mean it converges to what? It means when you're adding sufficiently many terms, when you add the sufficiently many terms, like the first 100 terms, if you want, what is it, the number you're going to get close to? So the sum equal to the first term multiplied by 1 over 1 minus the ratio. All right, the first term is minus 2 over 3 squared times 1 over 1 minus the ratio, which is negative in this case. So finally, I will get minus 2 over 3 squared times 1 over 1 plus 2/3. And the rest is simple math. This is going to give me 5/3, which is 3 over 5, which will give me whatever. That's going to give me minus 2 over 15. End of the problem. Okay. So actually, if you pick up your calculator and you start adding those numbers, I mean, really adding, you're going to get close to minus 2 over 15. The more you add, the closer you get. The more you add, the closer you're going to get. And probably after the break, we will do that, just to give you a feeling that it's really a matter of addition. It's really an addition of more and more terms. Yeah, any other questions? So as I said last time, so I will talk just for a few minutes. I have no intention of starting new stuff today before the spring break, because it will evaporate after spring break. But as I said yesterday, one of the only series we will really fully understand, we know there's some, is going to be the geometric series. After that, it's going to be very hard to find the sum, because the pattern will be impossible to pick up. I mean, for the geometric series, we found a formula for the Sn. So we were able to find a formula, and based on that formula, we said that that's what happened for the geometric series. So we are able to find a formula for, and then we said, you know, depending on the R, less than 1, converge, bigger than 1, it will diverge. For other series, it's almost impossible to find a general formula. So we're going to develop tests, just ideas. Okay, if the series will satisfy this condition, then it will converge. If it doesn't satisfy it, it will not converge. So we're going to be developing what we call tests to be able to check the convergence of a series. So for the last 3 minutes I have, I'm going to give you a series, and I'm going to ask you, if we finish, ask you, do you think it converges or not? So this is my series, sigma n over to n plus 1. N equal, let us say, 1 to infinity. Okay. So if n equal 1, I will have 1 over 3 plus 2 over 5, 3 over 7, 4 over 9, plus etc., etc. So the general term will be n over to n plus 1. Sorry, I wrote n, I should have written k. Okay. First question, is this geometric? Yes or no? Is this geometric?
I think so. Yeah.
What's the ratio? What's the ratio? If geometric, it means the way you go from one term to another by multiplying by a common ratio, by the same number. Is there a common ratio between the terms?
No, there isn't.
Absolutely not. Absolutely not. Okay, if you go from here to here, you have to multiply basically by 2/5 over 1/3. It means you have to multiply by, sorry, my mind went blank here. There is nothing. No common ratio. Do you think the series converge or diverge? So absolutely not geometric. Okay, one more minute. Do you think it converge or diverge?
Diverges
Because
it's not geometric.
no. Otherwise, we will not be studying for the whole 3 weeks about this stuff.
The terms are getting bigger as we progress, so I would think it would diverge.
Okay, keep saying. What do you mean the terms are getting bigger?
Like first we have 1/3, and then we have a larger number, 2/5, and then a slightly larger number, 3/7.
Are they larger? Are they really larger?
I think so. Yeah, they're getting closer to 1/2.
That's what I want. That's what I don't care about them being larger, but I care about that. Those terms is close to what? When n is large. This term, when n is large, is close to what? Quickly.
1/2. Okay.
What's going to happen here? I will be getting a half. I will be adding a half. I will be adding a half. I will be adding a half. The series will definitely diverge. Okay? So that's where we're heading after the spring break. For now, go and have fun over spring break and start taking your quiz.